Alright guys, we're going to be looking at lists and arrays. We're going to access arrays by using NumPy. And what is NumPy? NumPy is a multi-dimensional array library. So why would you use an array over a list? The main reason is for speed, and all of this information that I have given you guys, I found a good video on it made by this guy here. I included the link right here, and then also I gave you guys a reference document, and that gives you the really long-winded, like, how do you use each individual aspect of NumPy. But I'm going to go over some things individually to show you so you don't have to guess. Okay, so we've made lists already, so a list would look something like this. You say x is equal to, and then you could make your list 1, 2, 3, and then you can print it out, print x, and that's just going to print out a list of numbers. Now, if I wanted to multiply each one of those numbers by, let's say, 2, I would have to say, I mean, you can do it a whole bunch of different ways, but one of the ways you could do it would be, let's say I wanted to multiply the first number, x. I need to turn off this thing here. Let me turn this off. Disable. Okay. If I wanted to multiply the first digit by, I don't know, 2, I would say 0 and then times 2, and that would take the first digit here and it would multiply it by 2. As we remember that these are in order, this would be 0, 1, and 2. So if I run this, it's going to grab that first number and multiply it by 2. And then if I wanted to do the next one, I could copy and paste this and do it again. So then that would grab the next number. And then if I did it again, that would grab the next number. So then I would basically take each one of those and multiply them by 2. So let's run that and see what we get. And we get an error. Oh, I put 3. 2. And if I run that, we can see that we're grabbing each one of these and we're multiplying it by 2. So basically I'm having to break the list apart in order to run some math on it. So I'm going to show you guys a better way to do it and how they do it, you know, like if they have a bunch of numbers that they need to do a lot of calculations on, instead of breaking their lists apart and just running it, they use an array. So some things to go over with are why would you use NumPy? Well, the main reason is speed, less steps. It's actually stored a lot smaller, so it can be a lot quicker. All of the items in this list are numbers, so they can all be stored as an integer. So all of these are integers. So when the computer goes to reference this list or this array, it knows that they're all integers, so it doesn't have to do any extra steps to do math. So I'm not going to go into all the differences on that. Arrays allow you to use math on the whole thing. I think I already said that. And then this can also be used for like scientific calculations. So like on each one of the elements in your list, you can do things like, I don't know, mx plus b or y equals mx plus b. You can run an entire function on each one of those. What other uses do they have? They have, here, I'll type this out over here. Actually, I'll put it over here so you can see. And let me just put this. NumPy arrays can be used for mathematics, plotting, and machine learning. So like, I don't know if you've ever watched some of the YouTube videos like Code Bullet. He tries to make games where his creations, kind of learning and stuff. So this can be helpful towards getting you towards that. Okay. So this is how we create a regular list, but how would we create an array? How would we do that using NumPy? Well, the first thing we have to do is import NumPy as NP. You don't have to have this second part as NP. What that does is makes it where you can reference the function faster. So instead of typing NumPy every time, you can type NP. But we are importing NumPy, and I'm going to show you guys how to create your first array using NumPy. So I'm going to say, I'm going to reuse X. So all that stuff above is going to be pretty much wiped out. I'll comment it out or something in a minute, but X is equal to NP, which is referencing what we imported at the top. We're importing an array, or we're creating an array. And my array is going to be, I'll just use the same one up there. 1, 2, 3. So now I have, it's going to look very, very similar to what we just did. So if I even print it out, it's going to look identical to it. If I can get it right. Let's, oh, square brackets. There we go. So it looks almost identical to the one above, except for on this one up here, I had to break it apart to multiply everything. On this one down here, what I can do is I can say X is equal to X times 2. So that's what we were doing here. We were multiplying all of these objects by 2. Now, what I can do with this is I can just say multiply everything by 2, and you're going to see that it's going to go through the list and just multiply it all by 2. So if your list is 100 items long, instead of breaking it apart 100 times, you would just multiply by 2. Or you could even divide by 2. I mean, whatever you'd like to do to it. I haven't tried a whole bunch of these, but let's just add 12. Run. So you can see it adds 12 to all those. I mean, very quick, very helpful, good for plotting things, and you know, if you have a whole bunch of different stuff you'd like to do, you can do that very easily with an array. You can't do that with a list. If we tried to do this exact thing up here above it, it's not going to let us do it. It's going to give us an error because that is a list and that is not an array. Okay. Okay. Let's see, what was I going to show you all next? Okay, so this before I was telling you it can do this faster because of size, and they're all the same type of information. So let's see what, I'm going to comment out this stuff up here. And for what you guys are going to turn in on this, I just want to see this. If you have your stuff commented out, that's fine. Just have it all written. You know, take a couple screenshots so I can see everything that you've done. Okay. So what is the size of our current array? So I'm going to say print. And I want to know what is the size of, actually it is, let me find it. Oh, it's in bytes. So this is basically like a size, like you know how big a file is. Sometimes you have really big files. This is going to tell us how big is our array in bytes. So it is 24 bytes, and I'm going to put some words here. This is the size of our array. In bytes. So that's the size of our array in bytes. And what type of data is being stored? Meaning like integer, float, different string. What is it? And then I'm going to say this is what is being stored in the array. And then for this, I want to see what type of information is there. So I'm going to say x dot type, and it's going to tell us what type of, I think it's D type actually. It's not just type, it's D type. So it is storing a 24 bytes of information, and it is stored as an integer 64. So that is how much space it takes up. So by default, whenever I declared this array, it stored it as int 64. So I'm going to leave that one here, and I'm going to copy this, and I'm going to show you guys. Oops, how did I manage that? So I'm going to change this. I'm going to change the data type. Same everything, just going to change the data type. Nope, wrong one. I'm going to change the data type of this. So I'm going to say comma D type. Make sure I'm doing this right. I'm going to say int 16. Okay, so instead of using a 64 int, by default, I'm going to see if I can't change it to, or 64 by default, I'm going to see if I can change it to a 16. And you're going to see how it changes the size of the array. So it started out at, what was it, like, I don't know, 24 or whatever it was. This, if you know you're using smaller numbers, you can change the data type, and then the computer can do it faster. The actual like computations, it can do it a lot faster. So this is one advantage to using an array. Okay, I'm going to show you one more example, and then we're going to be done with this, and I'll pick up with this in a minute. Or we'll pick up this on our next assignment. Okay, so we did data types. Okay, so for the last part, I'm going to show you how to declare a multi-dimensional array. So this one is just a single dimension array. Let's make another one, and we'll do it. So I'm going to say x is equal to np dot array, and this time I'm going to have multi-dimension. It's going to have 2 dimensions, and then we're going to look and see what that looks like. We will use square brackets, and then another set, and 2 sets of square brackets in there. So I'm going to make 2 arrays. So if you can, I'll spread it out just a little bit so you can see what I'm doing here. We have one big array, and then inside of there we're going to have 2 smaller ones, or well, two arrays. So 1, 2, 3, and then over here I have, let's just do 4, 5, 6. All right. So I have 2 arrays, a multi-dimensional array. So let's print it out and see what it looks like. Print x, run. So it has 2 dimensions of it right there. 2 dimensions. Okay, so now you can actually check and see how many dimensions your array has without just like creating it and looking at it. Another way to do that is print, and then I think it's dimension shape. Print x dot shape. What that's going to tell you is how many. It has 2 rows with 3 columns. So if I added another one, let's see what it would look like. 7, 8, 9. Run. So then it has 3 rows of 3 columns. Okay. That tells us the shape of our array. This returns the shape of our array. All right. I think that's going to be it. What I'd like you to turn in for this assignment is just show me that you were able to do this. If you want to change the numbers in your array, that's fine. But just follow along with the video. When you're done, take screenshots of the work you did and turn it in. You guys have a great day.